double angle identities. Sine 2x is equal to 2 sine x cosine x. Cosine 2x is equal to cos squared x minus sine squared x. And that is equal to also to 2 cosine squared x minus 1. Also that is equal to 1 minus 2 sine squared x. For tan 2x is equal to 2 tan x all over 1 minus tan squared x. For half angle identities, if we take this, cos 2x is equal to 2 cos squared x minus 1. If we transpose negative 1, so that is 2 here. 2 cos squared x is equal to 1 plus cos 2x. Divide by 2. We get cos squared x is equal to 1 plus cosine 2x all over 2. So that is cos for half angle identities, cos squared x is equal to 1 plus cos 2x all over 2. If we take this, cos 2x is equal to 1 minus 2 sine squared x, and we transpose this, and we're going to transpose also this. We're going to have 2 sine squared x is equal to 1 minus cosine 2x. Divide by 2. We get sine squared x is equal to 1 minus cosine 2x all over 2. So that is sine squared x is equal to 1 minus cosine 2x all over 2. Also cosine x all over 2 is equal to square root of 1 plus cosine x all over 2. For sine x over 2, that is square root of 1 minus cosine x all over 2. For tangent, tan x all over 2, we get square root of 1 minus cosine x all over 1 plus cosine x, since tan x all over 2 is equal to cos sine x all over 2 all over cosine x all over 2. So that is why. Example, the derivative of 1 over 1 plus tan squared x. Remember our hexagon, if we divide into 6 here, and we draw curve just like this from left to right, from left to right, we have tan squared x plus 1 is equal to secant squared x. So that is d over dx is equal to 1 all over secant squared x. And we all know we have here, if we have secant, and the opposite of secant is cosine. So cosine x is equal to 1 all over secant x. If we square the cosine, we're going to square the secant. So that is d over dx of cos squared x. We can use chain rule. So for chain rule, we have here d over dx of, let me just remove this, dx of cos squared x, that is equal to 2 cosine x, and the derivative of cosine is negative sine x, and also that is equal to negative sine x, or 2 sine x cosine x, and also that is for double angle identities, that is also sine, negative sine 2x. Both of the two are correct. So there are also other method for this. If you have here using half angle identity, we all know that cos squared x is equal to 1 plus cosine 2x all over 2. So d over dx of cos squared x is equal to d over dx of 1 plus cosine 2x all over 2. That is d over dx of 1 half plus d over dx of cosine 2x over 2. The derivative of 1 half is 0. Since that is constant, the derivative of cosine 2x is, we're going to move outside the 1 half, and the derivative of cosine 2x. So the derivative of cosine 2x is what? That is negative sine 2x. And chain rule, so that is 2. The derivative of 2x is 2. We get here, cancel this. We have here negative sine 2x. That is example number 2. The derivative of sine squared x is equal to, we can use chain rule directly, so that is 2 sine x, and the derivative of sine x is what? Cosine x. So that is also sine 2x. We can also use half angle identities, so that is sine squared x is equal to 1 minus cosine 2x all over 2. So that is here, here d over dx of sine squared x, let me just substitute 1 minus cosine 2x all over 2. That is d over dx of 1 half, and minus d over dx of cosine 2x all over 2. That is 0, negative half, 1 half d over dx of cosine 2x, and we get negative sine 2x. The derivative of cosine is negative sine 2x, and we forget to add the 1/2 here. And chain rule 2, the derivative of 2x is 2. So cancel. So that is negative, negative. It will be sine 2x. Example number 3, the derivative of 2 sine x cosine x. That is derivative of what? That is double angle identities. So this is equal to sine 2x. The derivative of sine 2x is, we use chain rule, so that is cosine 2x. Chain rule, the derivative of this is 2. So that is equal to 2 cosine 2x.